Okay, June 2010, Edx M2, question number 2 on work and energy. So take a moment to read the question and then continue playing when you're ready. Right, here's a diagram for the first part of the question. We have to find the work done against friction as this particle slides down the plane. It slides a distance of 12 meters. Friction is mu r. We don't know mu yet, but we don't need it for this part. We have to find mu in part B. So here it's a case of applying the work energy principle, and as the object slides down the plane, we've got the loss of GPE, the loss of gravitational potential energy. Let's just jot that down. Is the gain in kinetic energy, and that would be it if it was a smooth plane, but it's not smooth, so some energy is lost, and the energy that's lost is the work done against friction, which we've got to find. So let's just put the numbers in then. So the loss of gravitational potential energy, the height difference, the h, is 12 sine 30 from this triangle. So we've got 0.6 g times 12 sine 30 equals a half 0.6 times 4 squared. The initial kinetic energy was 0, so that's the gain in kinetic energy done, plus the work done against friction, which we want to find. So I'll just call that WD. Simple equation to rearrange for us then. So WD equals, and if you get your calculator and check that, it comes to 30.48 joules. Now for the second part, we have to find the coefficient of friction. Now we know the work done by friction, and we know the distance the object slid, so we can find the frictional force, and then once we know the frictional force we can find mu. What we will need is this equation for the normal reaction, which comes from resolving perpendicular to the plane. There are no other forces apart from r and 0.6 g cos 30, which have components perpendicular to the plane, so we know r. So on the next page then, we know the work done against friction. We know that that's equal to friction times 12, because that was the distance that the object slid. And we know friction is mu times 0.6 g cos 30. So putting that all together then, the second part of the question then, mu times 0.6 g cos 30, mu r, times 12 must equal 30.48, the work done. And from that we get mu equals which comes to 0.4987, and that's the second part B, done for another 4 marks. Mark allocation for this then. For the first part, just go back to the first part. There was one method mark, 3 accuracy marks. The method mark was for the energy, the work energy principle. The accuracy marks were basically for the correct terms in these equations, so there was 3 of them altogether. We didn't need the R, the reaction, for this part, so accuracy mark there, accuracy mark for the answer, accuracy mark there, I think is how it went for 4 marks. For the second part of the question, again 4 marks. There was one method mark for setting up an equation with friction times 12 equals work done, so that the method mark was for this equation, and the other marks were one for the work done is friction times 12, that was a scene mark, B mark, one for the final answer, accuracy mark, and one for that. Okay, that's question 2.